Okay, all right, so I got it. So let me write this on my OneNote so we have it for later. Okay, so this is our review. Okay, so I'm just gonna go ahead and turn off my camera. Okay, so Mathis, what was the question you had?
It said for the equation ay double prime minus 5y prime. Oh, it should be a minus. Equal to 0. Where a is a constant, y1 equals e to the negative 7t is a solution. A second independent solution is question mark.
Okay, and you want to find y2.
And that should be e to the negative 7t.
Okay.
Yeah.
All right, so we want the second independent solution. Well, from what's given, we can just write out the characteristic polynomial. So we have ar squared minus 5r equals to 0. So that gives us r times a minus 5, ar minus 5 equals to 0. And then, well, we know one of the solutions. So if r1 is equal to 0, and then r2 is equal to, what is it? It has to be negative 7. Because this one,
Okay, I see.
You see it? This will give you the exponential solution, which is you have. So you have to assume that one of the root has to be negative 7 so that you have y1. So that means the second one has to be whatever that case is. In this case, it's 0. So that means our y2 has to be just any constant. So then now on the choices, you might see like y2 is equal to, it could be any constant, 10. And then another choice you could have, you know, something weird, 10a to the 5t, and so on. So you know this cannot be a solution because one of them in exponential, the second one has to be a constant solution because r1 is 0. So you would have to go with this one. And then it's 10 because once we put in an initial condition, that will fix what C1 is. So pretty much you can assume that y2 is just any arbitrary constant C1. Does that make sense, Mathis?
Yeah, much clearer. Thank you.
Okay, great. All right, so Connie, go ahead.
Yeah, I have actually two questions. One is very quick and the other one is just a clarification. So question 40, do you want me to screen share so I can show you?
Well, is it from the sample?
Yeah.
So let me open it up here.
Okay.
So don't forget our final is Monday, 1, 2, 3, 15. Okay, so which question was it?
40.
Okay, so here's 40.
So I solved it and I got, you know, the answer is like the 1 is true, 3 is true. I'm just not sure because you had the similar question and I think exam 2, where 4 you have 2y to the 6 whatever is a corresponding homogeneous.
Okay,
like,
well, this is similar concept but just different equation.
Yes.
So what's your question?
I think I'm confused with like what it's asking. So like I know the homogeneous equation is like C1 plus C2t plus C3t squared. But I'm not sure if it's asking that or if it's asking if this would be the homogeneous because it's equal to 0.
Well, so we want to check which of the following are true. So of course you're going to see more than one statement could be true or none of them could be true, right? So I don't have, of course, the remaining part of the question because it's not necessary. So you just go through each option. So first option, so the function y equals to something is part of the particular solution. Well, before we can decide if that's the part of the particular solution, we kind of have to solve the homogeneous first, and then we figure out the particular form based on the g of x we have here, right?
Oh yeah, I solved it, and this one is true, and so is 3, and then
Okay.
2, 5, and 6 are wrong.
Okay,
I'm just
so
not sure about
what about
4.
4? Is statement 4 true?
So I don't understand what they're asking. So
Well, statement
yes,
4 is
mhm.
statement 4 is saying this equation is the corresponding homogeneous equation to the given equation. Is that true?
If I understand the writing correct, yes, because this would be the homogeneous part and how we solve it. But if it's
Exactly.
asking for what the homogeneous equation is, then no.
No, this is the homogeneous, because if you just take the equation, so let me crop it right here. Because
Okay.
initially, if you didn't have the choices and you're just solving this equation, well, you have to set this equal to 0 to find the homogeneous equation, right? So you would have 2y sixth derivative minus y to the fifth derivative plus 6y that minus 3y to the third derivative equal to 0. So this is the corresponding homogeneous equation. And that's exactly what statement 4 is. Is this the corresponding homogeneous equation, right?
Yeah. I put yes. I just wanted to double check. And my next question is on question 42.
Okay.
So it
Well,
says,
let's pause. Does anyone else have any question on this problem so we don't have to come back to it again? Are you guys all with me?
Yep, we are.
Yeah? Okay.
Yeah, it's clear.
Good? Okay. So Connie, this is good, right? 40 is good?
oh yes, perfect. Thank you.
Okay. So what's the next question you had?
42.
42. What happened to 40?
Oh, it's not there.
Oh, it's gone. Okay.
There's one that's like not there. I think.
Yeah, sorry guys. I think I lost track of numbering it. I skipped 41. So
Yeah.
42. Okay. So what do you think?
For the Fourier series on the interval, the coefficient of sine 6x. So it's asking us to find the sign, which is bn, and this is an even function, so bn is automatically 0. But would you still want us to solve this?
No, so you just have to justify why is bn 0. So we're looking at an even function, and then you're looking for a coefficient of a specific term of bn, which is sine of 6 pi n, right? But because bn is 0, in general, it doesn't matter which term you're looking at. It's going to be 0 for all n equals 1 to infinity. So you just write one statement justification for something like this that doesn't require so much work. But you do have to justify it.
Okay, perfect. Because I solved it anyways, and it was so much work, so I was worried that because it's to the 4th power.
Yeah,
So,
right. If you see something like that, just think that there might be a quicker way to do it, right? So just think through the question: do I really need to do all of this work, or is the answer something I just need to think about it for a while? So just think and sit back and think. Okay, cool. So I do have one question from the chat. So let me just do that, and then I'll come back to the next person. So Christian wants
I
us
had a
to
question about 42 also. I don't know if
42.
we're going to come back to it.
Go ahead. Yeah, sorry, I forgot to ask.
Yeah. It was just a clarification question about when they ask for the coefficient of like the sine or cosine, they're asking for bn, right?
Well, we're looking for bn for a specific n value. So for example, if bn did survive, right? So you have the Fourier series as, so you have f of x is equal to sum n equals 1 to infinity, bn, and sine of n pi x over L. And if you expand this for a few terms, so if n equals 1, you have b1 sine 1 pi x over L plus B2 sine of 2 pi x over L plus B3 sine of 3 pi x over L, and so forth, right? It goes up to infinity. Now this one was asking, what is the coefficient of, for sine of 6 pi x? So what is L for this problem?
1.
1. So L is 1. So that means, no, this question wouldn't really do much because Bn is 0. But suppose you had L equals to 2. Let's just consider L equals 2. So if you plug L into this problem, just in general, okay, you have B1 sine of pi x over 2 plus B2 sine of 2 pi x over 2 plus and so forth. Now I want to know what's the coefficient of sine of, say, pi x. So that's what I want to know. So suppose that's the question. So that means, which coefficient are we looking for?
B2.
B2.
You're looking for when n is equal to 2, what is the coefficient of that term when you expand it? So you can see that we're looking for this term, but we want this coefficient. That will be the answer for that particular question. But for this one, funny thing, it's an even function. Odd function will get 0 for all n equals 1 to infinity. So therefore, it's 0. But some question, your term might survive. So if you just expand a couple of terms of the series solution you get, you will see which n I'm looking at, and then that will be your coefficient.
And Professor, just a follow up to that.
Mhm.
If say we did have something like this, right?
Yeah.
We could directly solve for it, right? Like we don't have to do the whole. We don't have to solve for B of n specifically. We could just solve for B of 2.
Well, you need the formula for Bn first, right?
I
And
mean,
then
yeah, right.
yeah.
But like, you know how it's the integral of it's 1 over L times the integral of
Mhm.
the function times sine of n pi x over L. Like, you know how you have sine n pi x? Can you just do the integral of the function times sine of 2 pi x over L, let's say?
So you're plugging in the value for n.
Basically, yeah.
Yeah.
Like, we could just do that, right?
Well, yeah, you could do that because that gives you the formula for Bn in general. But when you plug in a specific value for n, you get that specific coefficient. So yes.
Right.
Yeah. This is just, so I just show you in general. So that way you can see that, oh, this is my B2 if n is equal to 2 because I'm looking for the coefficient of this term. And this term happens to be right here when n is equal to 2, and that coefficient is going to be this B2 based on what we got from solving for Bn. Okay?
And also, so you didn't necessarily need to like, well, if you know that B2 is the thing that you're looking for, you could just plug 2 into the B of n equation, right?
So you could plug in 2 into the formula. So you have 1 over L integral from negative L to L f of x times sine of n pi. So n is 2 pi x over L dx. And that will be your B2.
Okay, and I was just wondering, what would the question say to find the other terms, like do they have specific names for them? Because in this problem it was like the coefficient of sine pi of x, but what about the other like a0 an, like how would they word that?
Well, they're called Fourier coefficients, right? For a specific term. So for example, this is your coefficient when n is equal to 1. This is your coefficient when n is equal to 2. So they're just called coefficients. Now, even for cosine series, you have f of x is equal to a0 over 2 plus the sum n equals 1 to infinity. Did we use an, right? Yeah. Cosine of and pi x over L. So if I want you to find the coefficient of, you know, cosine of 7 pi x, then you pretty much have to solve it, right? Find the formula for an, and then plug in when will this occur, so that way you know what n you're looking at, and then you can just plug that into your formula for an. Does that make sense?
Yeah, okay, thank you.
Yeah. So I think we had something like that on exam 4. So maybe just go over that particular question if you're still confused about this.
Oh, is there a way we can like check to see the questions for exam 4, or like see which one specifically we got wrong?
Yeah, Sunday, I'll make it available. I'm still finishing up the partial credit. So once I'm done, I'm hoping to be done by Saturday. And then Sunday, I will definitely make it available even if I don't finish.
Thank you.
Mm-hmm. All right, so now I'm gonna go to question, well, any questions on 42? Okay, cool. So let's go to 16. So let's see what 16 is about. Okay, so here is question 16. So you're given a differential equation, and now just by looking at this equation, what type of equation is this? Do we have a name for this?
Euler's?
Yeah, Euler, right? It's called Euler equation. Good, so it's in that quadratic form. So now, so you should know just by looking at it how the solution should look like. Even without even solving, you should have it in your mind. Oh, so this is the equation. I know how the characteristic, or we call it the indicial in this case, how it looks like, and then we know how the roots, and once you have the roots, you know how the solution would look like. So a solution to this equation is y1, which is x to the 4. Now, because you have learned reduction of order, okay, yeah, find the second linearly independent solution. Okay, so we know how the solution looks like just using Euler's method, but this question is asking you to use the reduction of order. So for reduction of order, what's the procedure?
Professor, just a quick question. If we were given like a problem like this on the exam and we did just solve it out using Euler's, would we get it wrong then because we didn't use reduction of order when you look over the work?
So, so on the test, it's not going to tell you which method to use, but here I'm telling you so that way you can practice that method. But on the test, you can use whichever method you're comfortable.
Right, so can I speak and solve the problem?
Sure.
So you could set y, the solution for y, equal to v. We'll say v is our v times x to the 4th.
Mm-hmm. So in this case, I'm using u. So which option would be the right option for this?
It would be c.
C, right. And then.
Oh, you want me to continue like finishing the entire?
Yeah, right. We can just chat, right? We don't have to solve it.
Yeah. Okay. So you do y equals u times x to the 4th, and then it would help to find the second and first and second derivatives of y. So you would get u prime x to the 4th plus 4x to the 3rd u for that would be y1. I mean that would be y to the first derivative, and y to the second derivative. You would just expand that. You would get u double prime x to the 4th plus plus 4x to the plus 4x to the 3rd u prime plus, and then you have the 4x cubed to the u. So you would also do that. You would have 4x cubed to the u prime times u prime plus plus 12x. Wait, no. Yeah, plus 12x to the second u. And then you would plug that in, plug y double prime into the what's it called? The original equation, and then y prime to the original equation. And then after that, you would just, I guess, solve for it. Like you would, a couple of terms would obviously drop off. I didn't solve it,
Right.
so
Yeah.
a couple of terms would obviously drop off. And then once you get that, you would integrate in terms of v, and then you would get v prime. Well, actually, you would do a second substitution. You would probably use, let's say, w equals to u prime, right? And from that, you would just solve for w, and then again for v, or I mean, in this case, u.
Right. So pretty much the procedure, Matir, thank you. You explained it a lot. So Matir pretty much give you the entire procedure, how to do it. We assume C is the solution
Wait,
form.
was I not supposed to? Sorry.
Oh no, you're supposed to. That's good. I'm glad you did, so I don't have to work it out. So thank you. So he pretty much explained how to do it. You assume C is the solution form. So then you take its first derivative, second derivative, plug everything in, simplify the equation, and then some of the terms will drop out. And then you'll see that it becomes a nice reduced equation. And then you come up with another substitution. And that will either reduce it to a linear equation or a separable equation from chapter 2 stuff. And then you know how to solve it from there. Okay, so Matir, thank you. So any questions on 16? So 16, you're just assuming which one is the solution form. 17 is when you're solving 16. So those are the steps. Any questions on 16? Okay, so well, any questions from anyone else? Okay, Josh, is there any question you want to go over?
No, I don't have any specific question to go over.
Okay, all right, and that's okay. Let's see who has question. So let's go over 15. So 15, oh, 15 is right here. Okay, oh, I already gave you the answer. Huh, how nice. Did you guys get B? Is that the answer?
Yeah.
Yeah?
Yeah, I got B as well.
Okay, so Josh, why don't you help us with 15? I'm gonna start writing too, so.
All right. So
Okay. Go ahead.
yeah, since the question already gives us well, it's a giveaway saying it's regular singular points, we're assuming the y would be wait, sorry.
Well,
yeah,
we're
X.
identifying what are the regular singular points. So how do we do that?
And so we look at P of X, which is X squared times 1 minus X squared, and we find all the X values that make it 0.
Mm-hmm. Good.
So it'll be 0, X equals 0, and plus or minus 1.
Mm-hmm. So pretty much just identifying what are the regulars. Well, I don't know if they're regular. What the heck? Sorry. Singular
Yeah, for
points.
now. Yeah, for now they're singular points, and then we have
Yeah. Sorry, I made a typo. What the heck I was thinking. But they're just singular points because that's when P of X is 0. So you just take your function P, which is in front of your second derivative, set it equal to 0, do some factoring or quadratic formula, whatever helps you. And then those are the points you're classifying. So in this case,
Professor, what is it called when it's not supposed to be 0?
Ordinary?
They're called ordinary points. Yeah.
Oh, okay. Yeah, ordinary. Thank you.
Oh, I see what I did. I'm so sorry, guys. I'm not thinking straight today. I want you to identify all regular singular point. So what we have is a singular point. So how do you know if they're regular or not? So sorry, I didn't make mistake on the question. I'm making mistake right now.
It's when you do, I don't know if there's a name for it, but where we plug in
limits?
The limit, yeah. The
Yep.
limit as x approaches the singular point of x minus the singular point, and then with q of x over p. And then the other one is x minus whichever singular point squared times r of x over p of x.
And then how do you know if it's regular?
if the limits are finite, it's regular, and if not, it's irregular.
Right. So we have 3 singular points, and we want to label them if they're regular or irregular. So I misread the question, sorry. I have singular points now. Now let's classify them. So I want to see if x not equals 0, if it's regular or not regular. So we take the limit as x approaches 0 of x times, so your q is going to be 2 over x, and then we divide that by x squared times 1 minus x squared. And then we try to take the limit. So what's the limit if you approach 0 for this?
It does not exist.
Well,
Right, so this is DNE. Okay, so that means you don't even have to take the second limit because one of them failed. So let's go to the next singular point. So x naught is equal to 1. So again, we take the limit as x approaches our singular point, which is 1 in this case. And then we take x minus 1 times the function q, which is 2 over x. And then we divide that by p. That would be x squared times 1 minus x squared. Now, what is this limit?
we say it's 0.
0?
Mhm.
Okay. Okay, I'll trust you. I'll say this is 0. And then, so now we can move on to the next limit and then making sure that that's also finite value. So as x approaches 1 of x minus 1 squared times r, which is the last function, that's 4. So sorry, I didn't label these. So this is p, this is q, and this is r. So r is 4, so we have 4 over p, which is x squared times 1 minus x squared. And then what is this limit? What do you guys think? So let's simplify, right? So you have the lim as x goes to 1 of x minus 1 squared times 4 over x squared, and I can factor 1 minus x and 1 plus x. And then I can cancel out this factor with, well, one of these, but I have to leave a negative 1 because they're just differed by a negative sign. And now let's see what this is. So we have lim as x approaches 1 of x minus 1 times negative 4 over x squared times 1 plus x. Now, is this limit finite?
Yep. Yeah.
Yep, this is also 0. So check, this is finite, this is finite. So x equal 1 is regular singular point. And then you do the same thing for negative 1. And you will also see that those two specific limits will be finite number. So that will also be a regular singular point. So that's why I have the answer 1 and negative 1. Not 0, because 0 is actually not a regular singular point. All right, so that's 15. Any questions on 15?
What does that say? D and E?
The limit does
Right.
not exist.
Right, does not exist. Okay, so any questions on 15? And then you can do a lot of stuff with 15, right? You can look for the series solution near one of these regular points, but that's going to be a lot of work because this function looks weird. Actually, I wouldn't do that because q is 2 over x, so I wouldn't do that. Don't do that.
Professor?
Yeah.
I was wondering if we could maybe go over problem 22, or
fine.
really any series solution problem.
Okay, so 22 is good, so let's do that one. So let me copy it right here. So here is 22. So we know that x naught equals 0 is a regular singular point, which means our solution form is going to be x to the r times the power series, which is the sum. I'm going to ignore the indexing because we just want the recurrence. I believe that's what the question wants, using the larger root. Okay, so we have an x to the n, and then I can push this inside, combine like terms. That will be the sum an x to the n plus r. So that means we can compute the first derivative of this. So we have the sum, ignoring the indexing, n plus r times an x to the n plus r minus 1. And then we can again compute the second derivative of this. So that will be the sum of n plus r minus 1, n plus r an x to the n plus r minus 2. And then we're going to replace this right here. We're going to replace this summation right here, and y, we're going to replace it right here. And then we're going to modify it, collect like terms, and then we have the recurrence. So, yeah.
I know the question doesn't ask for it, but do you think we could even go a step further and list out the first couple of terms of the equation?
Oh, yeah, we can do that. Because once you have the recurrence, you pretty much did all the hard work. Writing out terms is just fun.
For some reason, I always have trouble after I get the recurrence relation. Like, I don't know, I get mixed up somewhere and then I end up with the wrong.
Oh, yeah. Okay. Connie?
I said me too. I do also after I get the recurrence with the simplify. I get
Oh, okay. So that means you guys need to practice that. Okay, so let's do it. So let's see what we have. So we have x squared. So let me save some time. So if I move x squared into the second derivative, what would happen to this piece right here?
It would just change to x to the n plus r.
Right, because the -2 and the +2 from here, they cancel each other out. So I'm going to save some time and do that. So we have the sum n plus r minus 1, n plus r times an x to the n plus r plus, now what about the second term as I move x into the first derivative sum?
Negative
Same
1
thing happens to
disappears.
that.
Right.
XR.
Right, so, all right, both of you got it. So the -1 will disappear. So you have the sum n plus r an x to the n plus r. And what about the last term? What happened as you push x inside y?
It's going to be a to the n x to the n plus r plus 1.
Mm-hmm. So it's going to be an x to the n plus r plus 1 equals 0. Okay, so now is when you introduce that dummy variable k, so that every x has the same power, and we want it to be k plus r. So I'm going to do that right now. So I'm gonna like k to be n for this first one, k to be n for the second one. What about the last one? What is k equal to?
N plus 1.
Mm-hmm. And then here I also want to write down n is going to be k minus 1. Okay, so that's going to introduce that dummy variable, and then we're actually shifting the indices in the background, but we're ignoring it for now because it's okay. So we have the sum of, so the first one we have k plus r minus 1, k plus r, and I'm pulling out x to the r, so I'm going to put that at the end. For the second term, n is equal to k, so we have k plus r, a sub k, and then x to the k plus r, I'm pulling it out, minus 3. So n is going to be k minus 1, so this is a sub k minus 1. And then all of it, x to the k plus r equals to 0. That's it. Once you got to that step, you should feel good. I missed something.
Yeah, you missed the AK.
Where is it? Oh, for the first one.
First.
Yeah. Thank you. You see, you guys caught me. Good. So now here we set these equal to 0. So which subscript do we solve for?
Professor,
The higher?
I have
Okay.
Mm-hmm. Right. Saida?
So can you scroll up a bit? So I just remember this. Like on the homeworks, it would have like x squared plus 1, and then it would be like y double prime, right? So how would you like distribute that?
So you have x squared plus
Plus
1,
1 in parentheses, yeah.
like that?
I get confused on how to distribute that to the
Mm-hmm.
thing.
So, well, you just distribute the prime term. So you'll have x squared y double prime plus 1 times y double prime plus.
Oh, and then you just,
Yeah,
okay.
and then you just plug in your summations.
All right, thank you.
Yeah. So if you do see something like that, distribute first and then plug in the summation for each derivative. Yeah. Cool. Okay, so we're okay up to here? Yeah?
Yep, all good.
Okay, great. So now, like Matt said, we solve for the highest subscript. In this case, that would be a sub k. So I'm gonna move the negative 3 a sub k minus 1 to the right. So that will give me positive 3 a sub k minus 1. And on the left side, I have, and I'm gonna factor out a sub k. So you have k plus r minus 1, k plus r, and then k plus r. And now we can divide by those coefficients. So a sub k, it's going to be 3 a sub k minus 1 all over whatever that is. That's k plus r minus 1, k plus r plus k plus r. Okay. So now we need to use the larger root for this question because that's what the
Professor, can
question
you just
says.
factor that out and make it k plus r squared?
Where?
Because the denominator, because it would just be k plus r, and you would factor out k plus r.
Oh, yeah. You could simplify more. I was just
simplify to k plus r squared.
Mm-hmm. So I can factor k plus r, and then you have k plus r minus 1 plus 1, and then these cancels out. So like you said, this is just k plus r square. Yep. So yeah, you can simplify so that way you can get your coefficients quickly. So good point. Thank you, Matira. So now we want the larger root. So that means we need to find the initial equation so that way we can solve for the roots. So let's go back to the question. So what's the corresponding Euler equation for this?
So would you want to first take the limit of x squared times negative 3x over x squared?
So
to find gamma?
yeah, so what's beta and gamma when you take the limits?
I mean,
It's 1 and 0 respectively.
Okay, so that means our Euler equation is going to be x squared y double prime plus xy prime equals to 0. And now we can write out the initial equation. So that would be r minus 1 plus r equals 0, right? Yeah, okay. So what are the roots? We have r squared.
Just 0.
Oh, yeah, okay. Cool. So I guess that's the only root. See, if I plug in 0 for r, we have a sub k is equal to 3a sub k minus 1 over k squared. That's it. So that will be the recurrence relation. And then let's check. Does it look like any of these? Sub k
Looks like 2.
2. K squared on the bottom. Yeah, looks like 2. Okay, cool. So 2 would be the answer. Now let's write out some terms, right? So we know the solution is x to the r, the sum an x to the n. Now I always like to pull out x to the r when I'm writing out some terms, but if you want to keep it inside, that's really up to you. So we're using r equals 0. So we have x to the 0, the sum an x to the n. Now, of course, we know x to the 0 is 1. So this will just come down to oh, it's just the power series. Now, let's write out a few terms. So if I let k equals 0, I get a0, right? Now, I actually cannot let k equal 0. Why?
Wait, for k equals 0, wouldn't it be
Well, it gives us trouble on the denominator, right? So this is not possible.
wait, was I muted?
Yeah,
Oh, right.
yeah, Josh, you're back.
Yeah, I was gonna say that. Yeah.
Right, so k equals 0, well, that's a silly case, right? Because we get undefined coefficient, like what the heck. So let's go to k equals 1. So that will give us a sub 1. So a sub 1 is going to be 3 times a sub 0 over 1 square, which is going to be 0 because a0 doesn't exist. So I'm just going to say 0. What about k equals 2? If k is equal to 2, we get a sub 2.
Wait, Professor?
Yeah.
I'm sorry. Why is it that a0 is not possible?
Because of k squared on the bottom.
Oh, okay, I see.
So it's undefined, right? We don't
Okay.
say undefined coefficient. That's silly.
Okay, thank you.
Uh-huh. Now, what about a sub 2? Now, something is wrong with this question.
Well, if a's, oh, sorry.
Go ahead.
No, never mind. I was just.
Oh, this question looks weird when you write out the solution. I don't know why.
I always feel like this when I start writing out the solution, things start to get weird, and then I doubt whether I got my series right.
So everything looks like it worked out well. It's just that when you write out the terms, something doesn't work out nice. Because every term depends on the previous term. And our previous terms are kind of undefined, right? So I'm actually not going to continue this question. Because I probably didn't come up with the best question. So I'm not getting any of my coefficients.
There's nothing wrong with the root, right?
No, there's nothing wrong with the root. Everything is fine. It's just the question itself doesn't make sense.
All right.
So everything we did makes sense, but it's just that the equation itself, it's weird. It doesn't make sense. So yeah, it's a fault from my end. I didn't make up a good question. But the procedures are right. Okay, so Mathis, to answer your question, which I cannot do fully, but once you get these terms, if they do exist, then you just have to plug them in here. So you would have a0 plus a1x plus a2 x squared plus ... And then those are the terms you get from right here. But I don't have them here because it looks like it's invalid.
I also kind of have trouble where it's like when we start to plug in our n values, or I guess our k values here in this instance, if it's a higher, like if it's like a to the n plus 2, then obviously we get like a0 on top or something like that. And then when we're writing out the series solution to that, we just replace a2 with the a0. But
right.
how do we solve like what a0 and a1 are? Or it's not something that you can figure out?
So usually we like to keep everything using a0 and a1 because it's a second order. So you want only two constants. So think of your a0 and a1 are the c1 and c2 from previous chapter. Yeah. So that's why if you have a2, you should rewrite that in terms of either a0 or a1, whichever involves. So yeah, this question is totally weird, makes no sense. Sorry, I don't know what I was thinking when I made this question, but yeah, didn't work out well. So
I have a
omit 22. Yeah, go ahead.
If there is only like an x in front of the y double prime, you have to make sure it's at x squared, right? So you multiply everything by x.
Right, so we make it into an Euler equation.
Okay, got it.
Yeah. All right, so so any other questions on singular point series? All right, so any questions on other topics?
Can we go over Euler equations, specifically the different ones, like 23, for example?
Mm-hmm.
Because from this, I would assume that you don't do like the 3x cubed, because Euler, you know, it's the x squared that you count. I just want confirmation.
Okay, right. So so we're going to take those two limits to find beta and gamma. So that will give us the corresponding Euler equation. So let's go ahead and work on this problem. So just gonna copy that. So we're using x not equals 0 for simplicity, of course. So we know our Euler equation is usually x squared y double prime plus beta xy prime plus gamma of y equals to 0. So we're looking for what are these guys for this equation. So we know beta is going to be the limit as x approaches 0 of x times your function q, which is, this is q and this is r. So it's going to be q x over p, which is this guy right here. So that would be, now I'm going to pull out an x squared so that I can factor this nicely. So it'll be 3x plus 1. You take that limit, that's your coefficient b, beta. And then for gamma, we take the limit as x approaches 0 of x squared times r. So that would be 1/2 minus 5x over p. That's, again, I'm going to factor out the x squared. So that's 3x plus 1. And that will be your gamma. Whatever those numbers are, you plug them in right here. And that will be the corresponding Euler equation. So what's beta?
Should be 1.
So you see that these will cancel out. And then when you plug in 0, you'll have 1 over 1, which is 1. So beta is 1. That goes right there. And then what about gamma?
Should be 1/2.
Right. So if again, these will cancel out. And then when you plug in 0 for the x's, you will have 1/2. That goes right in there. So your corresponding Euler equation is going to be x squared y double prime plus 1x y prime plus 1/2 y equals to 0. Now, if you don't see this as one of the option, maybe the equation got multiplied by 2, so you got rid of the fraction. So you'll have 2x squared y double prime plus 2xy prime plus y equals to 0. So know how to do that, right? That's just algebra. So don't quickly go to none of the alternatives, because most of the time the answer should be there, unless.
Yeah, I didn't expect that.
Right, so I think, Josh, you had that in one of your questions, and
Yeah, it happened to me.
yeah, right, it was
I
the
just didn't
spring
expect
mass.
it to be multiplied. Yeah.
So try that the answers are there, and then if you don't see it, then I'll go with none of them. So work it out all the way. And also use fractions. I don't use decimals. I don't like decimals because you might want to use calculator for decimals, and we're not allowed to use a calculator, so I'll keep everything in fraction form. So it looks like, so what's the answer for 23?
Should be 3.
3, 2, 2, and 1. 2, 2, and 1. Yep. Looks like 3. Okay. Connie, does this make sense?
Yes, that's perfect. Thank
Good.
you.
All right. Okay. Any other questions?
Can you set up the equation for number 9?
Yeah. Number 9. Okay. Oh, let's suppose Josh want to borrow $7,000 to buy a car. Awesome. So let's buy a car. So I'll just set it up, and then I'm sure you guys can solve it. So 7,000, which component is that? Now this is a compound interest problem, right?
Mm-hmm. Wouldn't that 7,000 be initial value?
Mm-hmm.
IDP should be S0, right?
Yeah, so that's the initial condition, yes. So you're starting with this much amount. Now the lender charges, oh, I misspelled it. Okay, what the heck? Sorry, charge. Interest at an annual rate of 10%. So what's that? What component is that?
Should be the R.
Mm-hmm. R is 10%, and you always want to convert. So that's 0.1, which is 1 over 10. And then what else are we assuming? It's a compound interest continuously, and you're making a payment at a constant annual rate of K. So K is K, it's not given to us. So we're going to use K for K. But if I give you a number, say annual rate of $500, so that means you will be having K equals to 500, but because you're paying off to someone, it'll be a negative $500. But in this case, it's just a K. So we want to set out the differential equation with an initial condition. So we know that the rate is equal to, what's the formula? So we have R. Go ahead.
Yeah, okay. At this point, I don't, for this one, I didn't know which one to use, but I used the deposit one. So that I used RS plus K.
Now, why plus K?
Well, for this one, because for my initial condition, I put S0 is equal to negative 7,000.
Oh, okay. I wouldn't put negative money.
Yeah,
right?
because I didn't know how to tackle this, so I just put negative 7,000.
So because you're borrowing it from someone, you have 7,000, and then you have to pay it off, right? So you're giving it away every year.
Right. Yeah, I was thinking about I was thinking that because the negative 7,000 for owing the bank.
Mm-hmm. So we don't want to use negative money because that wouldn't make sense. So we want to use positive initial amount, but because I'm paying it off, so I'll put a negative K amount. So it'll be a negative for K, and then with the initial condition, 7,000. So plugging in R, we have the differential equation. R is 1 over 10 times S minus some K amount, which we don't know in this case. That will be the setup, and that will be the initial condition. And then this is a linear equation, so you guys should know how to solve this, and then, right? Any questions?
So in these kinds of problems, we don't use the C e to the RT.
Well, you have to modify that because we have a K in the picture. So if you remember when we studied, I believe this was 2.3.
Yeah, it's 2.3.
Right? Yeah. So if you look up your notes on 2.3, we did 2 types of application. We did tank, right? The salt. And then we did interest. So for interest, we again broke it into 2 scenarios. If there is no K involved, right? It's just the regular growth and decay, which we always do in pre-calculus class. So you're assuming that your ds dt is equal to r times s, and then that will be so your function is just going to be c e to the rt. But then when there is a K involved, we modified it. So our differential equation now becomes ds dt is r times s plus or minus K. And then we break this into cases. What would happen if K is positive? what would happen if k is negative? So do you guys remember what the solution is? Let's say if k is positive.
I remember.
Mm-hmm.
I think I remember for deposit, that's with plus k, right?
Right, that's plus k.
Yeah.
Because you're
Yeah, for
earning money.
Yeah. Yeah, because I just memorized them. So that would, the S of t would become c times e to the rt. I think it was minus k over s. Or r, sorry. Minus k over r.
For plus,
Deposit.
right? Yeah.
Yeah.
So it'll be minus.
Yeah, minus k over r.
Yeah. And then you
Yeah.
plug in the initial condition and then it will solve for C. So that's the formula. But of course you can solve it, right? We know how to solve this. How do we solve this type of equation? Well, what kind of equation is this?
Well, I was gonna say it's linear.
Linear. Yeah.
Yeah.
And that's right. It's linear. So you find the integrating factor mu and then, fill in the blank. And then you'll see that eventually after like 3 or 4 steps, your equation comes out to be that if k is positive and if k is negative. So if k is negative, then your formula just modifies just a little bit. You have c e to the rt plus k over r, and then you plug in the initial condition to solve for c. So just look over your notes if you need to revisit how do you solve from the differential equation here to get the function s of t. So by knowing these 2 models, can we answer the next part of this question? What is k so that you can pay off? Okay, so we did part A, and we want to determine the k value so that it takes you 3 years to pay off the loan. What does that mean? So what that means is you want the end balance to be 0 after 3 years, right?
Mhm.
Yeah, so you just set this up. So once you solve it, we're working with negative k case. So we want s of t to be 0 when t is equal to 3. And then it will just set it up. Any questions on this? Harold, does that make sense?
Yeah, thank you.
Okay. All right. Yeah, so really know how to set it up. Setting up is really important. I'll probably not make you solve it.
Professor.
If I want you to solve it, I'll give you a different differential equation, what I want you to solve, okay? So most of these will probably be setting it up, but you'll see what the question is asking. Once you know how to set it up, solving should be really simple. Yeah, let's hear, was it you?
Yeah, that was me. C from what I recall, C is just S naught plus K over R, right?
Well, if you plug in the initial...
If K is positive.
Right, so if I plug in the initial condition, right? So so I have, what do I have? That's what I have, right? So if I plug in 7,000 into, so we're using this formula, the one with minus. So we have 7,000 is equal to C e to the RT, which is 1 over 10. So that's 0.1 T minus some K over 0.1. And then, so if you solve for C, you would get, what do you have? Actually,
Would you get S naught minus K over R?
yeah, so you would get 7
minus.
Yeah, so 7,000. Oh, yeah, minus K over R, which is 0.1, is equal to C e to the 0.1 times 0, because T is 0. So C is going to be 7,000 minus K over R, which is 0.1. Yeah, Yeah, you're right. So, and then you just plug that in here, and then it modifies again.
Wouldn't it be negative? Wouldn't it be e to the negative RT?
Yeah, did I miss a negative somewhere? Well, why would it be negative? No, I think it's positive, because if you solve it, right? Because, so take a look at this equation. If you solve it, you have ds dt minus r s equals to negative k. Well, so let's use that. So your mu of t is equal to e to the integral of p. So that would be negative r dt. So you have e to the negative rt is mu of t. And then if I multiply that with my differential equation, so I have the derivative of mu e to the negative rt times s of t is equal to negative k e to the negative rt. So let me just get space. So that means on the left side we have, so we integrate, right? And then you have e to the negative rt, s of t is equal to, so if I integrate the right-hand side, what do I have? So k is a constant, r is a constant. We're integrating respect to t. So we get k over r, e to the negative rt, plus c. So that's when the c comes into the picture. So I should really use different color. Right, this is confusing. And then I'm solving for this guy. So my s of t, it's going to be, I divide both sides by e to the negative rt. So you have k over r, e to the negative rt to the negative rt will cancel out. So then you have plus c e to the positive rt, because you divided by negative rt to bring it on top, the exponents become positive. So it's positive e to the rt.
Oh yeah, okay. And just clarifying question.
Yeah.
That's irregardless of whether k is positive or negative, right? It's
Well,
always
no,
going to
no,
be
no.
e to the positive
No.
RT.
Well, so right. So this is always the same. What changes is this piece right here, depending on the k value.
That and c, right? Because
Exactly, because c will
Okay.
depend on the initial condition. Yeah. Okay.
when you okay,
Right, because whatever this is, right, that will determine what c is. Right. What's here? Do you follow?
yeah, I got it. Thank you.
Okay. All right. So really, there's two cases for the compound interest, if k is positive or if k is negative. So make sure you know both of them, and then once you have the initial condition, you can find that c. So any other questions on this topic? Are we okay with this topic?
I don't know. I think I'm okay.
Okay.
Not certain.
No. So which part would you like me to go over again, or?
No,
maybe-
everything's fine. It's just that I'm stupid and I don't know which one to use.
Oh, well, so Josh, let's
I
think
understand.
about it this way.
Like I understand for deposit, like it's
Right. So suppose you open a bank account and the bank charges you some interest, and you start off with $1,000, and every year you're inputting $500 into the account. So are you increasing the value for yourself, or are you decreasing the value?
sorry. We borrowed from the bank, right?
Right.
Yeah. So we're
No,
increasing our.
no. You didn't borrow. You're opening an account.
Oh, we're opening. Sorry, and we're depositing. Yeah, we're increasing the value in the bank. Yeah.
Right. So that means you're adding k to the amount you start with. So that would be a positive k.
Yeah, I think it's because the problem is that I didn't so I just memorized the s of t immediately. I just didn't bother to I didn't bother understanding the derivation for s of t. So
Okay.
that's why.
Yeah, so I would say maybe focus on that too, because once you know if your k is positive or negative, then you can determine which formula to use, right? That could be
Right.
memorized. Yeah.
Yeah, it's 'cause- yeah, I just memorized S of t. That's why.
Okay, so I would say really for everyone, look into the problem and see, are you adding money to some account or are you giving it away to somebody because you borrowed money? So if you're giving it away, it's going away from you, so that would be a minus k. But if you're earning, then that's a positive k. And then from there, you know what the model is. So maybe that might help, not sure, right? But try to see if you can revisit those homework problems. All right, so any other comment or suggestion on this topic? Okay, well, see, applications are always a little bit more confusing because you really have to understand which modeling are we using, how are we setting up the equation. So it will take you a little bit more time than when you're given an equation, just solve it. So that you can do it blindly, right? But for application, it'll take you a little bit more time to think and process. Okay, moving on. Well, any other questions from anyone? Okay, so what about the, let's take a look at the ones at the end. So since we have a series and Fourier stuff at the end. So we did talk about 42. Now, how are you guys doing with the heat equation?
Pretty good.
Yeah. Oh, that's exciting. So I guess 43 is okay. Yeah, right. 43 looks fun. Okay. Now, what about 44? So 44, you really have to do some work because for the first part, you're looking for the Fourier Sine series. And then for the second part, you are using the first part to write out the solution to the heat equation. So are we okay with the heat equation stuff?
I solved this. If somebody else solved it, we can compare answers. I'm not sure if it's right though.
Okay, so for 43, right?
Uh-huh.
Okay, so for 43, Connie, what's your answer for A? What is Bn?
For Bn, so I didn't really simplify, but 18 over n cubed pi cubed 1 minus, over 18 over n cubed.
Oh, okay.
Pi cubed times, like in parentheses, 1 minus cosine n pi.
Okay.
And if somebody got a different answer, please let me know.
All right, so who got a different answer or same answer? So did anyone work out 43 or anyone else?
No, I wasn't able to reach this question.
Okay, so Montier, what about you? Were you able to do 43? Oh, sorry, 44. Sorry.
No, I haven't reached 40 yet.
Okay, so so Connie, let's do it. I'm gonna work it out for you, and then everyone else can compare their answers with mine. So this is 44. Sorry, not 43. Connie, did you give me the answer for 44 or 43?
No, 44.
Okay, all right. So it was just me. I wrote it wrong. So we want to. So let me copy the question here. So those of you who haven't done the question, just make sure when you do work it out, compare your answers with mine. So, so we want to find the Fourier Sine series for Okay, so for some function on the interval 0 to 3. So what does that mean? Well, that means that we're doing an odd extension of this function. So that means an is going to be 0 for n equals 0, 1, 2, and so forth. So a0 is also 0. So that means we're only looking for bn, and bn is given by 1 over L integral from negative L to L f of x times sine n pi x over L dx. So what is L for this problem?
Should be 3.
So that's L, because this is the interval 0 to L, so L is 3. And now, because f of x, we're extending it as an odd function, so this is odd. Sine is also an odd function. So what's the product of two odd functions?
Even.
So that means I can do 2 over L, go from 0 to L, f of x times sine n pi x over L dx.
Yeah, I was about to ask the question.
Yeah.
So just because it's asking us to compute the sine Fourier series, we assume that f of x is odd, right? But if it was cosine, we would say it's even, right?
Right. That's correct.
Okay.
Yeah. So now let's go ahead and plug in f of x. So f of x is going to be, so 2 over 3, because L is 3, we're going from 0 to L, L is 3, x times 3 minus x, sine of n pi x over 3 dx. Now we gotta do some integration. All right, so here is my derivative column, and here is my integration column. So we're differentiating the polynomial, and I will distribute the x as well. So you have 3x minus x squared, and we're integrating sine of n pi x over 3. Okay, so okay, we got some work to do, so help me out. So I'll do the differentiation, you guys do the integration. So you have 3 minus 2x, and then if I differentiate again, I get negative 2, and the last column will be 0. Great. So now, Josh, help me out with integration.
All right, the first one should be negative 3. Negative 3 times cosine n pi x over 3, and all this over n pi.
Okay.
And then the following one, well, I was going to say negative 3 squared sine, then everything inside of that, and then over all of this over n squared pi squared.
Okay.
And then the last one is just 3 cubed times cosine, everything inside, and then all of that over n cubed pi cubed.
Thank you. All right. Okay, looks great. So now I'm going to multiply this with that and put a plus sign, multiply this with that, put a minus sign, and last one. Okay, so now let's write this out. So the integral of this function is going to be, so we have 2 over 3 in the front, and then we get the integration and the differentiation from the right side. So we have negative 3 over n pi times 3x minus x squared cosine of n pi x over 3. And then the double negative will cancel out, so that's plus 3 minus 2x times 3 squared over n squared pi squared times sine n pi x over 3. Oh, so running out of space. And then the last term will get a negative sign, so that's a negative 2 times 3 cubed over n cubed pi cubed times cosine of n pi x over 3. And we're evaluating all of these from 0 to 3. Okay, so now let's be clever, right? We want to cancel out the term that goes to 0. So as you plug in the upper limit 3 into all of these, what happens?
Sine should go to sine functions go to 0.
So this one will go to 0. Now, what about the first term? 3x minus
yeah.
x squared. That one too, right? Because 3 times 3 and then minus 3 squared, that's 9. So this will also go to 0 when we plug in the upper limit 3. And what about the bottom one? Will that survive? Yeah, right?
No.
No?
No. The first expression?
And this one.
Oh, we're looking at the one. Oh.
Mm-hmm.
For 3. Yeah, I will.
Yeah, so we have only the third term surviving when you plug in the upper limit. So we have 2/3 in the front, and we have negative 2 times 3 cubed over n cubed pi cubed times cosine of n pi, because x is 3, so that 3 cancels out, yeah. Now, minus now the bottom limit. When you plug in 0, what happens?
Both, the first two expressions, both are 0.
So this will go to 0 for the bottom limit. This will go to 0 for the bottom limit. Now what about the third one? That will survive. So we have a plus 2 times 3 cubed over n cubed pi cubed times cosine of 0 is 1. Whew. Okay, that's good, right? We simplified a lot. So now let's just make this look prettier. So I'm going to go ahead and, yeah, I don't want to do 3 cubed. What's 3 cubed? 27. Actually, I'm just going to keep it as 3. So we have 2 over, well, I can actually, yeah, I can actually cancel this 3 with one of these and just reduce it to 2, right? You guys follow?
Yeah.
Right? We can do that. So I can factor out 3 cubed and then reduce it with the 3 from the bottom. So I'm left with 2 over 1 times, and then 3 squared times negative 2 cosine of n pi plus 3 squared times 2, and everything over n cubed pi cubed. And now we can actually simplify this more, because cosine n pi, what happens to that term?
It just alternates from 1 to -1, so you can rewrite as -1 to the power of n.
Right, so we know cosine of n pi alternates between 1 and -1, so we can just write that's -1 to the n. And now you can split this up into cases. So you have, so let me just rewrite this again. So I'm going to distribute the, maybe no, I will just wait for the 2 to be outside. So we have 3 squared over n cubed pi cubed, and inside the parentheses I have -2 times -1 to the n plus 2. And then this can be broken into piecewise. So what happens if n is odd, and what happens if n is even?
For odd values, well, you'll get a value here that's not 0.
So if n is odd, so right here, so we get a -1 times -2, that's a +2. So we actually have 4 inside the parentheses. So we have 2 times 3 squared times 4 over n cubed pi cubed. That's when n is odd. Now what if n is even?
It's a 0.
0. So our coefficient for, I forgot which one we're solving, bn, right? It's going to be just that number for every odd integer of n. An odd number, you can write that as 2n minus 1 or 2n plus 1, depending on where you start the problem. So what is our bn? Well, our bn is going to be, now if you multiply these numbers on top, is that 18? I don't think that's 18.
18 times 4.
18 times 4.
36.
Okay.
4.
72?
Yeah, I think so.
Yeah, okay. So that's 72 over n cubed. Well, n is odd, so that's 2n minus 1 cube pi cube. So that's my bn. So Connie, make sure you double check what
Okay.
went wrong.
That last 4, I must have forgot it somewhere.
Yeah, so you're very close. So yeah, this is a long problem. So if you got it right, good job. So this is good. So now what is our Fourier sine series? So the Fourier sine series, it's going to be f of x is equal to the sum from n equals 1 to infinity of bn, which we just found, 72 over 2n minus 1 cube pi cube sine of n. Well, that's 2n minus 1 and pi x over L, which is 3. So that will be your answer to part A. Okay. Any questions? So yeah, this is a lot of work. So just make sure you do it very carefully, because if you don't get the coefficient right, then the heat equation, if it involves that, then that's going to be wrong also. Now, what do we need to do for part B? So part B is not a lot of work, because we already did most of the work, right? So how much work do we need to do for part B?
I mean, you just plug everything in, right?
Yeah, you just plug everything in where?
Into the series solution for the heat equation.
Yeah, so we know the heat equation, the solution to it, up to the boundary condition, right? It's going to be what? Oh, go away. All right. So do you guys remember the heat
Oh yeah,
equation?
yeah. It's
Josh, I'm listening.
yeah. So summation of bn, which we found bn, times e to the negative alpha squared n squared pi squared, and should be over, is it over L squared?
Mm-hmm.
L squared, then times t, right?
Yeah.
And then, and then sine n pi x over L.
Yeah. So there you go. So just make sure you remember this. So that's up to the boundary conditions, which are always 0. So now we have an initial condition, which is exactly same condition as part A. So that means you already know Bn. You already solved it. So Bn, we're going to plug in from part A, which is 72 over those terms. So this is the same Bn we're going to use for the heat equation. And then, well, what is L? L was 3. And what is alpha square? We need that as well. So what's alpha square?
Should be 1 over 5.
Mm-hmm. So alpha square is 1 over 5 because the standard way of writing the heat equation is U sub t is equal to alpha square U sub xx. So the 5 needs to go to the second partial respect to x. So you divide both sides by 5, which makes alpha squared to be 1/5. So we have alpha squared, we have L, we know n is odd. So plug everything in, you have your solution to the heat equation. So this is the sum from 1 to infinity of Bn, which is 72 over 2n minus 1 cube pi cube, and then e to the negative, so I'm just going to write it like this, 1 over 5, n is 2n minus 1 square, pi square, and then L is what, 3 square times t, and then this will get multiplied by sine of n pi, well, n is again odd, so 2n minus 1 pi x over 3. And then you just simplify those numbers, 3 squared times 5, whatever that is. Just do that right here. Okay. So that will be a setup for heat equation. Any questions? Does it make sense?
Yep.
Yeah.
Okay, cool. All right, so yeah, that's it. So so I hope I went over a majority of them. So just work these out, and then also try to focus on the homework problems too, because if you forgot something, this might be a good time to review. And then skim through these problems. You don't even have to solve all of them if you don't want to. A lot of them repeats, right? Like number 4, I already gave you a higher order, like a couple of them. So if you got the basic idea, you don't really have to solve all of them. But just make sure you understand each topic. And there might be topic that I left out. I can't remember it right now. But just make sure to review your exams. Homework problems, really important that you get those out. And then this practice. And then there also practice on the department page. So if you go to the mathematics department and then go to courses and then scroll down to 391, just right here. And then there are plenty other practice exams posted here. You can do the ones that have solutions, such as fall 2006. That one has solution. And then spring 2011 has solutions too. So you can work on those problems, and then I think you'll be in good shape if you do enough practice.